Good morning, everyone, and thanks also for Gert for making his way from Europe actually to New Zealand. Thank you very much for that. Now, before Gert starts talking about testing from a DevOps point of view, I would like to take the opportunity to set the foundation. Firstly, what is actually the main driver, the main business driver behind DevOps? What is the difference between Agile and DevOps? And last but not least, what is actually the future of testing? What is going to change in order, and what needs to change in order to fully support a DevOps approach from a testing perspective? Now, the main business driver for DevOps is go-to-market or speed go-to-market, as well as the revenue for operations. It's all about speed. And Gartner, as well as Forrester, the two main IT analysts in the market, they say different systems require different speeds. And they categorized the systems in several groups, and the two main groups are highlighted here. So one being the system of records, and the other one being a systems of engagement. So now what is the difference, and what has that to do with speed? So system of records contains and maintains all crucial business information, business data for an organization, right? So for example, obviously these are the main transactions that run in the back-end office. It includes, enterprise resource planning systems, CRM systems, the core databases that host all of these data. And if you have a data warehouse, then obviously it's about the business intelligence, the analytics that you run on it. What defines these systems is that they are very stable and very reliable, as opposed to the systems of engagements. Systems of engagements are these systems that allows an organization to interact with their customers or their partners, right? For example, obviously a main driver of system of engagements are smartphones, mobile devices, or modern web applications, HTML5 based, that enables very modern applications for online banking, for example, right? But then there is also the whole movement about social media, and last but not least also Internet of Things. So embedded objects in devices that allows you to exchange data. For example, you all know the Fitbit bracelets, right? Which is all about sensors, built-in sensors that collect data from your body and actually sends it to here, right? And then you can do all sorts of things. So these are the main systems of engagement. And obviously, these systems are driven largely by customer needs. And there you are in a competitive situation to other organizations. So it will require a complete different speed than these systems down here. What these systems are characterized with is also they need to be ease of use is crucial, as well as performance. Now, from a speed perspective, systems of engagements have far more frequent releases. We talk here about weeks, down to days, and in certain exceptional situations, mostly seen in companies from the US like Amazon, they even have more frequent releases. At least this is what they claim. And then on the other hand, you have obviously the systems of record, where you will see, probably also from your own experience, that these systems have far less frequent releases. But it's not once a year anymore. They are still quarterly or monthly releases. And why is that? Because there is a dependency between the systems of engagement and the systems of record. Because obviously if you release here functionality very quickly, obviously there will be an impact down here as well. So you also face different or faster release cycles from a systems of record perspective. Okay? So the main business driver, to recap again, for DevOps is go-to-market speed. Now, what is the difference between Agile and DevOps? Now, it's all about collaboration. It's a collaboration between different functional teams. In Agile, it's about the collaboration between the business and the development, including testing. It also enables or seeks for early feedback, obviously, as well as early feedback about what software, what code we are delivering, as well as that changes can happen at any point in time, right? So these are some of the core fundamentals of the collaboration that we seek between the business and the development. Now, by adding the operational aspect, the main thing that changes is that we have an additional people taking part of that collaborative team. And that now includes the business, the development, and the operations. What is fundamentally different is this one here. An agile team is focusing on delivering software, code, whereas a DevOps approach is looking more holistically about delivering a system, because it includes hardware, configuration, deployment, and all sorts of things. So it has a wider scope. What will not change is actually that you will have daily stand-ups. What will not change is that you have an iterative approach to software development. What will not change is the early feedback that you're seeking. And what will not change is that you have the burn up, burn down transparency about how you actually perform as part of your DevOps team. The love of agile, collaboration. Okay, let me make that clear when I actually put that slide together. So now, look, different people understand different things about DevOps, right? And for example, they look at code as infrastructure, or they look at it from a cultural perspective, or they talk about Kanban, right? So it depends which role you have and which view you take. So let me allow you to actually use Agile as a starting point to explain you DevOps. And with that, I would like to start with the top level philosophy. I would assume that you all know the Agile Manifesto. So the first of the four is the individuals and interactions over processes and tools. Working software over comprehensive documentation. Customer collaboration over contract negotiation. And last but not least, responding to change over following a plan. Whilst we value the right-hand side, we value the left-hand side higher than the right-hand side. That's important. Now, there are strategic approaches that supports actually these values. For example, the highest priority is about customer satisfaction. That's on the forefront. As well, or combined with allowing for change of requirements at any point in time, right? And there are more. And then obviously there are the methods, strategic approaches, methods that actually represent the implementation of these principles. And here we talk about extreme programming as an example, about Scrum or Kanban, so just-in-time lean approaches to software development, or your homebrew process, for example, a waterfall Scrum-like thing, okay? And last but not least, these are the tactical techniques that actually support these methods. And here we talk about the stand-ups, the planning focus, the backlogs, and collaborative development and continuous integration. So that's all about Agile. Now the question is, what is changing or adding if we are now talking about DevOps. So what is changing or adding if we talk about DevOps? Only two areas. The first one is we're not talking about code anymore. We're replacing that word with systems. Very important. Because again, it's about continuous deployment. So you look at far different aspects than just deploying code. And last but not least, you're adding additional practices in order to support DevOps. So let's have a closer look at these practices. So this is one of the graphs I really like. This is the eternity symbol, you know, the 8 turned down on a horizontal line. And what you see here now that we are actually adding continuous release and development. We are adding continuous feedback. We are adding continuous monitoring, and probably the one that is of the importance to us here and the reason why we are all here today is about continuous testing. These two came from the agile world, right? Continuous integration and collaborative development. Now, what is your agility? You know, Bank West, for example, which is one of the companies on the forefront of agile and DevOps in Australia, at least. They are part of the CBA group. They had actually, it took them 5 days to go through a full regression cycle with a smoke test, right, as part of their online banking application, right? And then they actually asked the developers, how quickly do you need feedback? And they said, better not longer than a coffee break, because this is how long it takes me to do a build, and then I want to have the feedback. So what they achieved is, then they asked, how long is the coffee break? They said, well, 12 minutes. So what they do now, they run a full smoke regression test, including white box and black box tests in 12 minutes, several times a day. And that's what's in here. Okay, so this is what we want to achieve. Now, this bandwidth here is largely determined by your work in progress. Work in progress is your agility. So if it takes you several weeks to go through a regression cycle, so your agility is several weeks. And if it takes you 12 minutes to go through a regression cycle, then your agility, at least from a testing perspective, is 12 minutes, right? And whatever it takes from a lean management, what you want to eliminate is work in progress. You want to make this work in progress as short as you can. Work in progress is waste, right? So you don't want to actually avoid that. Now there's more to it. Now, there are different environments in DevOps, and you might all be familiar and have heard about these environments. So there's a development environment, there is the test environment, the staging environment, and the productive environment. And you have certainly heard about the shift to the left from an agile perspective. Now, what does that mean from a shift to the left from a DevOps perspective, right? So what it means is that we actually do development and testing in production-like environments as early as possible. So that's the shift to the left. We want to test in a production-like environment as early as possible, and with that, reduce cost, because the earlier you can find defects, the less costly it is, as well as increase the quality. Now, let's talk quickly about continuous testing. So the definition of continuous testing is that continuous testing means testing earlier and continuously across the entire life cycle, which results in reduced costs and shortened testing cycles and achieved continuous feedback, again, feedback on quality. So this is all about continuous testing. Now, to achieve that early cycles, there are certain stuff to happen. For example, virtualization in general is very important, because without virtualization, you will never manage to actually offer product or production-like environments early on. Service virtualization will be another one. So you need to simulate the systems that are actually not available early on because you don't have the production environment. And last but not least, that's probably one of the most important things, is that according to the World Quality Report, the reliance on manual testing is the #1 testing challenge in the app world. Now, what does that mean? Today, we do 80%, roughly 80%, plus minus, in manual testing. And the manual testing is largely spec-driven testing. And only between 15 and 25% is automated. And even more shocking, or not really shocking, but kind of illustrating where we stay today, a very little part is API. Now, when you want to shift to the left, the only way how you actually do unit tests and component tests is using APIs, right? So this is far too small. So in order to really support DevOps from a continuous testing perspective, when the budget won't increase, is reduce manual testing. There will be no manual testing that are spec-driven in DevOps going forward. Most testing done in a manual fashion will be exploratory testing. And you will see that in detail in Gert's presentation. What will significantly increase over proportionally is the fact about testing as early as possible against non-graphical user interfaces and the help of service virtualization to simulate production-like environments. Having said that, graphical user interface testing, UI tests, are still increasing, but not as much as the tests against APIs. And these 80% up here, they're all spec-driven. And this is where you also will hear about test design when Gerd will take over. How can we actually come up with all these spec-driven test cases with a minimal amount of test cases whilst maintaining a certain risk coverage? Now let me go back to this slide before I hand over to Gerd. Now, in these three environments, development, test, and staging environment, you will still have the same types of tests. And you're all familiar with these types of tests. So we talk here about unit tests on the left-hand side. Here, component testing. So that's mostly done in the development environment here. And then system testing, system integration testing, and user acceptance testing. Now, there are two main types of tests that you will need to execute, and they are complementary. The first one is a white box test. And a white box test, the ultimate goal is to provide a code coverage so that you cover all the parts of your code by doing a white box test. A white box test requires access to code. That means you run these types of tests predominantly in the dev environment because this is where you have access to code. There might be exceptions that you might also have access to here, but predominantly it's on the left-hand side. Access to code is also mostly only available to bespoke systems that you have developed on your own. It's less available to commercial off-the-shelf or shrink-wrap software, such as SAP, to name an example. Okay. On the other hand, we have black box testing. So, on the other hand, we have black box testing. And black box testing is looking at the system from a black box perspective and only uses its interface that it offers to interact with. And there are two fundamental types, one being a graphical user interface and the other one an API, a non-graphical interface. Okay. Now, when we talk about unit test and component test, for example, testing, you have a web service where you can actually access an operations or a method through the service. So you can actually run a unit test in black box mode from a service API layer. And then obviously you have system testing, system integration testing, which might be a mix of both API as well as UI and UAT, last but not least, is mostly UI driven. Now, if you allow me to make one remark regarding Tosca, Tosca will actually support you in all these 3 areas, supporting a shift to the left from a black box testing perspective. But there's more to it. Whoops, here. We also support exploratory testing. We have excellent support for test data management, including test design, and last but not least, as well as service virtualization. And with that, I would like to hand over to Gerd.
So welcome from my side. I don't know if I should say good morning or good afternoon, because I think my body feels like it's in the middle of the night, and we're in the morning here. So I arrived yesterday from Austria, from Europe, to the lovely country of New Zealand. I've been here a couple of times before. I really like it. Just a quick introduction of myself. My name is Gerd Weiser. I'm the VP of Product Management. That's the good news, I guess. I'm actually in charge of what goes into Tosca. And the bad news is I'm not a salesperson. So whenever you see my demos, they will not be as polished as maybe a sales demo is, but I'll show you the things that are, I guess, most important for you. Okay, so let's jump into this. I mean, Thomas' introduction was really interesting because he started to talk about a little bit more of the high-level aspects of DevOps. About a year ago, we had first conferences in the US where we attended, and they were all talking about DevOps. And honestly, I wasn't really sure if this is going to happen or not, right? There's 2 fundamentally different cultures that are coming together. There's agile development and there's operations. I'll speak in my slides about this. What we've seen so far is that, I mean, I would say even in Europe is always lagging behind a little bit. Customers start talking about DevOps. Okay, this is becoming real. In the US, it's a big hype. In Europe, it's starting to become real. And what I've heard so far here in Australia, in New Zealand and Australia, it's becoming more a trend as well. Okay, so let's jump into this. I'm going back in history first of all. Okay. When I started computer science, that was a while ago, my first project was in the steel industry. I was born in Linz. It's a small town between Salzburg and Vienna, dominated by the steel industry, actually. And what we did is I created an information system for the steel industry to predict energy consumptions. Sounds complicated, and it was complicated. So we probably spent, I would say, half a year to write down all the requirements and specifications. We talked with all the plant managers. We learned and studied the plant behavior. Everything was documented and written down. Okay. We designed the system. We implemented about 12 months, and we delivered the system like 18 months later, with the result to find out that whatever they told us that the plants would do was completely irrelevant. The predictions that we delivered were not even close to what the system was doing. And that's, for me, you know, the biggest problem with this waterfall approach is you spend 18 months here doing all this work at the end to just find out it's not the system that you wanted. It's not doing what you wanted. So we more or less scratched that system and started from scratch again with different methodologies and so forth. But that was my first big project, actually. You can add this up. The numbers are, it's really expensive when you find out at the very end that the system is not doing what you were expected to do. So in the evolution, you see up here, that's like we're still crawling. Let's move forward. I actually started to work for a company that invented the UML at a later point, Rational Software at this time. And Rational Software was interesting because they came up with this Rational Unified Process. I don't know if, are you familiar with the Rational Unified Process? Okay, yeah, Thomas, that goes all the way back when Thomas and I met for the first time, actually. It was in Switzerland at this time. What I really liked about the Rational Unified Process was it was the first approach to create an iterative development model. Right? We had extreme programming at the same time, roughly, but it was like structured by those phases. And within those phases, you had different activities, like business modeling, requirements, design, and so forth. So the idea was that you would go through these iterations and do activities from all these from these categories. So when you look at the level of activities, though, in here, you see that most of the modeling is done in the beginning. Requirements are done in the beginning. Then you get into design. And so when you look at this, like in this line, it awfully looks like a waterfall to me. So this is more like a water scrum, fall-ish kind of approach. It was better than, I think, waterfall, but it still had the same shortcomings. You would find a problem really late in the process. So then we got agile, right? So we're now walking like a Homo sapiens, and we do agile, and I love it. I mean, I really love it. Tricentis is an agile company. We do Scrum, only Scrum. We have short sprint cycles, about 1 or 2 weeks, depending on where we are in the project. And it works. It works fine. We have small teams, 4 to 6 people. They are very agile. We don't spend too much time on talking and documentation. We get the most risky things out first, and we have deliverables immediately, right? So basically the idea from agile is you do something real quick, you deliver a valuable product at the end. That's great. And this product, you hand over to the guys from operations, and they will make it work. They will put it in the production environment, and they keep it running. You do this with every release, right? That sounds perfect. I mean, why do we need a DevOps? Well, the problem is when you hand it over and it doesn't work, which happens a lot of the times, the operations people start to scramble. They spend the weekend trying to fix the databases, trying to fix the operating system and everything. And when you talk with them, they complain a lot about certain things. I've got a few quotes here. It compiles, therefore it works. That's a development approach, I would say. My favorite is, it works on my machine. I mean, you must have heard that, right? It's like you find a problem, well, it works on my machine, it can't be a problem. But there's other quotes here too, and it's like when you want to have a quality assurance environment and you ask the operations people, it takes them years, literally, to give you that environment that you need for testing. How are you supposed to test your software if you don't get the environment, right? And that's something we will address also when we talk about the virtualization. Thomas already mentioned it. The shift left means that we start earlier to test, which means most of the components might not be available. How are you going to do this if you have a service-oriented architecture, for example, right? You need to simulate those services, and I'll speak about this. Okay, so the solution is, and please notice the graphic here, it took me a while to find that, is the DevOps. DevOps is now bringing together 2 different cultures. Agile, eager for speed to do things, get things out the door. Operations, don't change too much, okay? It's working, please, don't put too much in my system. It should be working afterwards. And these cultures come together in a cycle that I would say the biggest change here is really the cultural change in the DevOps movement, but then also you have the process change because those activities need to go seamless and into each other. You've heard about the new terms that you see here. Thomas positioned us as the continuous testing company. Well, for continuous testing, I would say the short version is at any point in time, you should know what the quality of your software is. That is continuous testing. So you test everything you have. And so Thomas's animation, this is what is expected in a DevOps environment from you. I don't know who in this room is already embarking on a DevOps journey or adventure. Is anyone doing DevOps in here? Okay, that's good. I always hear those stories from Etsy, Facebook, and so forth. They release every 12 minutes. Is somebody releasing every 12 minutes in here? I mean, but more or less the expectation will go towards that, okay? As soon as we have this established, they will expect this from us, okay? And I really want to use this only as a segue, is like, how do we achieve this speed? What do you think? How can you achieve that speed? Absolutely. That is the solution. So we can end this presentation right now, right? Because we solved the problem, we're done. I would say let's take a closer look at this first. I used to have an example for this when I drove from Boston to New York City. I used MapQuest, actually. And then MapQuest kind of looked a little old-fashioned, then GPS came out. So let's use Google Maps here as an example to illustrate something. We have a situation, right? We have two locations. We're in point A, and we need to get to point B. The question is, how do we get there? The fastest? We automate. We take a car or whatever is driving. We print out or we get the route, and then we drive there. Do you think this is the best route that we could find? Yes, no? It depends, I would say. If you're a UPS driver and you have to pick up packages, it might be actually the best route. So the question really is best for what? How do we optimize those criteria? If we are an ambulance and we have a patient in the back with a heart attack, this, I agree, is not the best route. Probably this might be the best route, right? So what I'm trying to make the point here is before we start buying automation tools and then starting automation, we should think about what are we actually trying to achieve? What do we need to automate? Where can we optimize? And the third step in the whole DevOps movement, which I think is really exciting, is the whole integration. So I don't know if you notice, sometimes with the ambulances, when they approach an intersection, the traffic lights switch. They switch off and make it green light for the ambulance. In this case, you are 100% sure that this is the fastest route. Okay? So the 3 steps are optimize, automate, and integrate. And that's how I would like to structure my presentation today and take you through those steps one by one. Okay, optimize for business risk. When we meet customers, in our first conversations, we ask, so how much business risk do you cover? And the answer I typically get is 5,000 test cases. I'm like, I'm sorry, how much business risk does that cover? And they probably repeat 5,000 test cases. What is the problem with the number? 5,000 test cases does not tell you how much business risk you cover, right? So let's say you're agile. You develop, with every sprint, you get more tests and more tests and more tests and more tests. It's just a matter of time until you reach a critical limit. The critical limit is it takes more time to execute all these tests than you have. What are you going to do in a situation now? What are you doing now? You have more tests than you can execute. Prioritize. Prioritize, yes. Very good. How do you do that? Huh? Yeah, so typically what we see is when you don't have a business risk approach, there's a smart QA person that has a lot of experience. The guy comes in and prioritizes the test cases. That works in some situations. I will show you some statistics about this. The answer is absolutely correct. You need to prioritize and you need to focus on the high-risk test cases first. Then you can do the medium, and then at the end, if there's still time, you can do like lower risk cases. So yeah, this is just another attempt. When we do methodology, and I will show you this, there's one thing we need to be careful about is we need to avoid like an exponential growth of test cases. There's nothing worse than you have a portfolio of 10,000 test cases. Nobody knows what they're testing. They're typically redundant for 67%. That's what we see in our projects, right? So you want to have a lean portfolio of test cases that focus on the business risk that they cover. Okay, so maximize the risk coverage, minimize redundancy, minimize the test portfolio, make it maintainable, something we don't always think about when we start a project, right? You started, it's nice, you create your test cases, but after some time you actually need to maintain this. So it needs to be maintainable, and if possible, it should be reusable. And Tricentis has always stood for that we actually say you need to do a systematic approach to that business risk. That's really important. Now, why is that important? I'll give you some background here. If you have test cases, and let's say you have n number of test cases, 5,000, 10,000, whatever your number is, and you have time to execute m, what's the percentage of business risk that you can cover? Well, typically the answer is m over n, something like this, right? You calculate the percentage. So now somebody would say like, yeah, but I'm not using weights on this. We don't weight them. Well, the truth is actually, yes, you do. The moment you don't use weights, you actually make them equal weights. across the board. And in this case, what you get is when you look at the risk coverage here and you look at the test cases that you have here, what you assume is that there is a linear growth. For every new test case I add some incremental business risk that I cover. That's the basic assumption behind this, right? So adding more test cases is a good thing because I'm incrementally increasing my business risk coverage. That's, I guess, the logic behind this. So what's the tricky part with that? We did an analysis of over 100 projects. We looked into which test cases found which defects, critical defects, and you get a graph like this. Okay, I'm not trying to get scientific here on you. This looks like pretty much, I don't know, it looks a little bit random to me when I think about where you find the critical defects. Now, if you do this across 100 projects, the variations that you get in those values is even bigger. These are the standard variations around these percentages. And what you see is that actually, after like 50%, you can't really say how much you found. There's no real information in there. You can't say how many critical defects are still in there. And I think that's the worst part. If you have to release, and you can run 50% of your test cases, you more or less don't know how many critical defects are still in your software, okay? If we change the approach and we put weights on those test cases, okay, we have a risk-based approach. We can talk about this in the break, but we put weights on the requirements and we put weights on the test cases. We call it contribution here and we call it risk weight on the requirements. And if you put them and if you sort them according to the risk contribution and weights, you get a distribution like this, okay? This is commonly known as a Pareto distribution. It's the 80-20 rule. Because with 20% of your test cases, you get actually almost 80% of your risk. So if you look at the defects that you will find, the curve turns into something like this. So now you are able to say that within, let's say, the first 40% of your test cases, you can find the absolute majority of your critical test cases. And this is really why I'm saying, like, you have to look into a systematic approach for test case design. Now, here's a chart that we see when we talk to customers. I mentioned that you have this experienced quality insurance manager who does the prioritization. He will typically get to like around 40% of the business risk. That's what we've seen in the project. It's not because that person is not smart enough. Actually, that guy is really smart. He has experience in everything. It's just that after that, the complexity of the test case portfolio gets too much. You have 5,000 test cases. Nobody knows anymore what that test case, where it contributes in business risk. So that's when you become redundant and everything. And that's when we say you have to do a methodological approach in this case, okay? Is anyone using a methodology in here for test case design? Yes, which methodology are you using? Okay, orthogonal, okay, yeah. Yeah, okay. So I'll have some methodologies here real quick, just to give you like a one-on-one on this. One that is commonly known as all combinations. Do you know that? It's taking more or less every instance and tries every combination. This is simplified. We have 15 attributes and 2 instances. In this case, we get 2 over 15, which is 32,768 test cases for this simple combination, okay? The advantage is it's exhaustive. You have maximum coverage. You can do this if you develop software for, I don't know, for a rocket launcher. And in some areas, you need to be like 100% proof that you tested it. In all other areas, this approach is not doable, okay? The problem is you have exponential growth, and it's not, you can't do this anymore in an economic fashion. This is the explosion in the previous chart that you've seen. One point that we will hear over and over is, what is the test objective of each of these test cases that you get? right? You get a combination of attributes, and you will have to look at this. And some of your people, some of your testers needs to be able to say, oh, in this case we tested, I don't know, the trucks with gas and, I don't know, a payload of this and this. Somebody needs to be able to understand what you tested with this test case, okay? And this is really hard in this. The problem, if you don't understand this, it's going to be hard to find what the reason is why the test failed. Now imagine you run your regression portfolio overnight, 50 test cases didn't run through. And now you have to dig into this and try to find out what the problem was with the application. So the other methodologies are pairwise. Pairwise is a little easier. It takes combinations of two. There's also triple-wise, quadruple-wise, and so forth. The biggest advantage is you only get 20 test cases. So you kind of manage the complexity, which is the biggest advantage here. The disadvantage is the test objective is not clear. So you get all kinds of different combinations. Some combinations might not even make sense, right? You need to kind of like build in relationships between attributes. Let's say there is no car that should have, I don't know, like a diesel, for example. There are obviously, but you have to build up relationships between those two attributes and forbid them. All the pairs are equally important, which is not true. It is not true. There are pairs that are more important than others, okay? And the same problem with the root cause analysis. Orthogonal, here we are. What is the biggest advantage? In this example, it's the clear winner of the test cases. We only need 2 test cases for this. So you get the absolutely minimal number of test cases with this. What is the problem with this? It's really hard to read those test cases. When you take a look at them, how they are put together, the purpose of a test case is more or less hard to find. Enormous maintenance problems. Whenever you add attributes to that, it becomes difficult because you more or less have to kind of like look into redoing a lot of the test cases, okay? And finally, a methodology which we promote as the best one, it's called linear expansion, okay? And linear expansion in this case produces 16 test cases. So we're a little lower than pairwise, we are higher than orthogonal, right? You had 2 with orthogonal, we have 8 times that. But in this case, we have 16 test cases. And how does it work? Well, with linear expansion, you define one specific test case, which is called a straight through. It's the happy path, the most important flow through your application. And this will be, in this case, we call it truck with petrol. It's not very useful in this case, but this one is the purpose of this test case, okay? And from there, every other test case will be a deviation from that straight through by only one single attribute. Okay? This one, we switched the first one into car. So now this is a car with petrol. Okay? The next one is a truck, and actually we changed that to diesel. So this is truck diesel. The next one is truck large. Why? Because it has a bigger payload. Then we have a truck small, and so forth. So you get all these test cases that only divert from the straight through in one attribute. So the assumption is that this straight through will always work. This is what you would put in a smoke test. If you run a smoke test, you would use the straight through. Chances are developers use this as well for their own testing. Okay, that's the most common test case that you have. The big advantage is, you might have some more test cases as we saw, but they are unique and well-defined. So every test case has a label on it. Whenever I show you a portfolio, you can pick one test case and we'll say like, oh, truck with payload over 2,000, and you know exactly what that test case did. That's basically the idea behind it. And this is quite important. We also developed an algorithm that you can actually calculate the risk contribution of each test case. Okay? So now doing this risk-based approach, you have the requirements that have the weights from the business side, but you also have the weight or the contribution from the test cases. That means if somebody asks me, like, we have to go live tomorrow, how many test cases can we run? I could tell you that we can cover roughly 60% of our business risk. If the business side decides that this is enough, then that's fair enough, right? Because otherwise you have no way to say something. I can run 500 test cases overnight. But that doesn't tell me how much business risk you actually covered. Okay? So this was really the part about the optimize. Okay? The idea is you need to create a portfolio which is optimal. I have a case study at the very end of my presentation. I will show you the transformation from a non-business risk-driven portfolio into a risk-driven, and then with automation, what improvements you can achieve. Okay, now let's switch gears a little bit here for the future of test automation. This was something that I created with our founder, Wolfgang Platz, about probably, I don't know, it's a half a year ago. We talked about what's the current situation in testing. And the reality is when we come to customers, we see those numbers. Thomas brought them up. My theory is that there's a reason why this is only at 20%. Every one of you bought a test automation tool at some point, right? And probably a capture replay tool. Looked so nice when the salespeople showed it, right? Worked so perfectly. And then you had to use it, and you found out that actually it's not that easy. It's hard, and test cases start breaking, and the maintenance problem gets bigger and bigger. That's why I think my theory is that this is only down at 20%. For DevOps, we need to get to this automation explosion on this side. And like Thomas mentioned, right, in this area, we have API and service virtualization. I think what you will see in the future is those two areas will melt together, okay? Service virtualization and API testing will more or less become one. You will be able to test your APIs, and next time you switch it and simulate that service, okay? That makes perfect sense. UI automation needs to grow as well, and then we have the last 15% here, the exploratory testing, which I think is a better way to do manual testing because you actually get your testers excited about it. I mean, there's nothing worse than going through a scripted manual test case and clicking one step after another, right? Anyone can do this. Exploratory testing actually gets your attention. People get excited about it, they love it, and they find more defects with it. Okay, so let me go through this kind of like, through this in this order, what we have. Before I jump into this, into the testing part, the one question that I have is who is doing this? We want to have this transformation from here to here, let's say in the next 5 years, okay? That's a good goal. Who is doing that? In a team structure, what could this look like? And what we see is that you would have your agile team, and you have the testers in there, which would be like a manual tester or automation expert, as we call them. They will be doing the exploratory testing. They will create the regression tests for the sprints. They will be supported by something like a test design specialist. This will be the person that chooses the methodology and builds up the full test sheets. Probably will be in charge of the overall regression tests and things. And then you will have some automation engineer here, which is actually supporting these guys to have all the modules and the infrastructure in place, custom controls, understands the technology behind it. That is more or less the approach like we practice it in our own organization. This is how we test our software. And the question always comes up, is the test center of excellence, is it going to die? We believe that it will be transformed. We don't think it's going to die completely, but it will be transformed. It will look different. The testers will be a valuable part of the Scrum teams. That is really important. Exploratory testing is the first testing that was on the rainbow chart. I call it the rainbow chart, actually. What's the biggest difference between specification-based and exploratory-based testing is with specification-based, we set a very clear scope of what we are testing. Typically, there is some sort of documentation, or there is the requirements, the user stories and everything, and this is what we test, okay? And when you do a good job, you find most of the big problems and critical areas in that. But there's other areas that are surrounding. It could be either, I don't know, general UI issues, usability issues, right? When you give a power user your software, you will learn a lot about what the other people didn't think about. because they will use the software in completely different ways. And this is really what actually the idea is, I think, with the exploratory testing. So exploratory testing is outside of the scope and will also find areas outside that area. We also talked with customers that are doing only exploratory testing. They don't do specification-based testing anymore. They will also cover these areas through targeted exploratory testing. Okay, so the spectrum from exploratory testing is pretty wide. You can find the freestyle. I give you 2 hours, take a look at the application kind of style. And there is session-based exploratory testing as well. Session-based exploratory testing is, I think it was promoted first by James Bach. James Bach and Michael Bolton, actually, were doing this. And the idea is that you have a certain charter which tells you where to focus on. And if you use session-based exploratory testing, you can also do the complete testing in here, because you will have charters for all these different areas. And then you time box your exploratory testing to, let's say, 1 hour. So you will take a look at the new customers for 1 hour. Okay? So that's kind of like, and then you start exploring this area and you start testing this. Here's a quote from James Bach, which I think is the most valuable part on this exploratory testing. It makes it intellectually rich. Okay? There's numerous studies that show that people that do something that they are interested in or that is fun do a better job. Okay? With this, you make it interesting and exciting again to do manual testing. These people will find all the defects that other people that were scripted maybe wouldn't have even seen or ignored while they looked at the screen. It was right in front of them, but they followed step 2, right, and didn't see it. So that's something I think is really valuable. So when you start exploratory testing, you would structure it by, I don't know, release cycles, for example, or sprints. Within your releases, you have different sprints, right? You have sprint 1, sprint 2, and then let's drill down and say you have the sprint here. In a sprint, we will have 2 test sessions. Okay, that's just an example structure to keep it simple here for you. And when you look at this, what you see here is, put a point back, you see this would be a test session as you would structure it. You would have, the administrative part, your owner and everything. You would have a progress bar here that shows you where you are, how many sessions have been executed, what did they find. And here you would find your charter, for example. The charter is the document that actually describes what the people should be looking for. There are specific notes that you can add per test to look into, I don't know, a payment service on this test for Mike, and Gernot should look into something different. But this would be roughly the starting point where you would structure your testing session. Now let's go into Ingo's test here. And I double-click this. So this is what Ingo's test looks like. Ingo is an employee of mine. He actually tested several scenarios in here. And what you see in those scenarios, you see the start time, you see the end time, you see the total time that he actually spent in exploratory testing. When I go on one of these scenarios, just to show you, what you can find it here is that Ingo attached a screenshot and a video. What is the big challenge with exploratory testing, really?
Documentation.
Exactly, the documentation. You click around for 20 minutes, all of a sudden you find a defect, you're super psyched, but you remember the last 5 steps only. You don't know how you really got to that, right? And it's not enough information that you can submit it to the developers that they can actually reproduce that. So basically the idea is that you need something to document this, and I'll show you this in a second. In this case, it would be a screenshot and a little video. You see let's see, here we have test steps in here. So we can structure this in different ways, okay? Let me just, where do I have my test application here? The way I can start a scenario is different. We have customers that are very structured. They want to more or less have a description for their scenarios. So you can start from a manual test case even. So I could say, let's start this here. I could say, let's start with this test case here. And what you will see is this is the test assistant here that helps me document this. If I open this up, you see actually I loaded more or less a test case with all the test steps in there. So this is really guided. This is extremely guided in my understanding, but you can go through this and you can actually say pass or fail. You can attach screenshots and whatever you need for these. This would be extremely guided on the one spectrum. And let's close this here. And let's start a session just from scratch. Okay, so this one is empty. What I would do is I would actually create a step and say start app. Okay, enter. And then I would just like go here. Sorry. Go here and do a start application. Okay, so we pick the automobile. Brand of car, any preferred brands? I'm a big BMW fan, so it's okay as long as it's not Volkswagen. Volkswagen got a really bad reputation in the US now. 250 kVs. That's I think that's a decent engine. And let's just ignore this and click for it. So now there's problems, right? Obviously. So I come down here, and now I'd like to do a screenshot and take this information here. This is the screenshot I just took. Now let me add some text. What is missing? List price wrong. For whatever reason, this is wrong. And I can point to that too. This price wrong, okay? So this would be a picture, for example, that if I found something in the UI that doesn't work, I would save that and send that to the developer. So the developer would get that screenshot and would be able to simply take a look at this and more or less change what I found. A different way, let's say I'm coming here and I'm going back. I'm going back in this application. We go to this level. A different way how you would approach your testing is by simply starting a video capture session. What is the advantage of the video capture session? Everything you do on the screen will be recorded. Okay? I can select which windows I want to record. I just take the primary window here. I say recording. Now you see the recorder is running down here. And everything I do now is captured like in a movie. So I can actually go up here. We do the same game again. BMW. Okay, this time we want to have a little bit more horsepower. And let's just do this. Click on the list. Oh, oops, we ran into the same problem again, okay? So at this time, I would actually stop my recording. I could pause it as well. Now, so this is what, it opens up the video now that I just recorded. Okay, it's already running. And you see me clicking on the application. BMW, 300 horsepower. So, and this is where we found the problem, right? So let's wait here, stop. What did we say last time? The list price. List price is wrong. Wrong. Okay. Let's do this and let's. The same way, like I annotated my. Where's the list price? List price here. The screenshot. I do this with the video as well. Okay. And by the way, usually those sessions are long. Right? So you don't want to submit a, I don't know, 45-minute video to a developer. He's going to sit there for the next 45 minutes and watches what you just did. You just take this, you crop it in and say like, okay, where is it? Where does it get interesting for the developer? Let's put it here. I think that's enough, right? That's what he should see. And we save. Okay. So, okay, I'm still running on the, on the mode. Go back here. Okay, we're still on the, sorry, I just jumped around now. Let's save this now. Okay, we have the video here. So we have the video here now in this session where I recorded it. And while the video is in Tosca, it is actually a video file and the comments and annotations together. What I can do now is I can easily export that video and save it as an MP4 file. I wouldn't assume that the developer actually, that the developer has Tosca installed, for example, right? So you just want to send him the video. I could do an export of this video here, and could, in this case, it transforms actually my annotations. They become now part of the video. There's nothing I could edit anymore. And now I can actually export it before I drop it again. And I can say, what is that? BMW problem 2, okay? We save it. Encoding is completed. And now it opens up the BMW problem 2, and anyone who has a video player or whatever can actually use that video to find the problem. Okay? This should be enough for the developer to actually be able to see what you've done. Try to reproduce it, fix the problem, and check it into the code. In the next step, what you would do is you would actually create a test case for that. Because you want to avoid that the same problem will not be tested in the next release, right? So this is where it actually is pretty handy when you document your test steps. In the beginning, it looks like this is lame. You have to document every step. Once you have your defects and you want to do regression testing, it gets much more interesting to do that, actually. Okay? So this would be like a simple overview of exploratory testing, how you could do it.